The universe is full of strange and wonderful things, planets, stars, galaxies, but some of the most fascinating objects are the ones we can't see directly: black holes. These are places where gravity is so strong that nothing, not even light, can escape. A cosmic trapdoor. Most people know about stellar black holes, born when massive stars die and collapse under their own weight. But there's another, more mysterious kind: primordial black holes. Primordial means from the very beginning. These black holes weren't born from dying stars. Instead, they may have formed in the chaos of the Big Bang, in the universe's first second. Back then, the universe was a hot, dense soup. Tiny fluctuations in density could have collapsed directly into black holes, no stars required. So, we have two types: stellar black holes, the end of a star's life, and primordial black holes, relics from the dawn of time. Stellar black holes are confirmed. We've detected their collisions through gravitational waves. Primordial black holes are still hypothetical, but finding them would be like discovering a fossil from the first second of creation. They could change our understanding of how the universe evolved. This isn't just an academic exercise, it's a cosmic detective story. These ancient objects might hold the keys to the universe's biggest mysteries. They could explain dark matter, the invisible glue holding galaxies together, or be the seeds that helped the first stars and galaxies form faster than we thought possible. If we can find them, we might unravel a whole new tapestry of the universe. So let's dive in. Let's explore these cosmic seeds and see what they can teach us. The story of primordial black holes is a journey to the universe's very beginning, and it might just rewrite everything we know about our cosmic origins. To understand primordial black holes, rewind to the first fraction of a second after the Big Bang. The universe was a seething, hot, dense plasma, pure energy and particles packed tighter than anything we can imagine. In this chaos, tiny fluctuations in density appeared, some regions denser than others. Normally these ripples would smooth out as the universe expanded, but if a patch was dense enough, gravity could overwhelm expansion, causing it to collapse instantly into a black hole. No dying star required, just pure energy and matter squeezed into a point. That's a primordial black hole. These could form at many scales, some as massive as thousands of suns, others as small as a mountain or even a car, but squeezed into a space smaller than a proton. Imagine a black hole you could hold in your hand, if you could survive its gravity. The window for creating primordial black holes was brief. As the universe expanded and cooled, the chance vanished after about a second. If they exist, primordial black holes are true relics, fossils from the universe's first heartbeat. They carry a snapshot of the universe's infancy, a time we can't observe directly. They're messages in a bottle from the dawn of creation. Studying them could reveal secrets about the earliest moments of everything. These black holes are more than cosmic oddities, they're time capsules. If we find them, we'll have a direct link to the universe's birth. And that could change everything. After the Big Bang, the universe was a dark cloud of hydrogen and helium. No stars, no galaxies, just gas. Gravity slowly pulled this gas together, forming the first stars over hundreds of millions of years. But telescopes like Hubble and Webb show us galaxies that formed surprisingly early. Primordial black holes could be the reason. Imagine the universe dotted with these cosmic seeds, each a point of immense gravity. They'd act as anchors, pulling in gas and speeding up the formation of stars and galaxies. It's like building a snowman. Starting with a rock makes it faster than starting from nothing. Primordial black holes would be the rocks, gathering gas quickly and igniting the first stars, giants called population 3 stars. This theory explains why we see mature galaxies so early, and how supermassive black holes could form at galactic centers. Instead of growing from scratch, galaxies could be born with a primordial black hole at their core. These seeds would grow by swallowing gas and stars, becoming the monsters we see today. The largest structures in the universe might have been planted before the universe was even a second old. Primordial black holes could be the missing link in cosmic evolution. When you think of black holes, you probably picture stellar black holes born from the death of massive stars. These have a minimum size, always at least a few times the mass of our sun. Primordial black holes are different. They don't come from stars at all. They formed from dense regions in the early universe, so their masses could range from tiny to enormous. Some could be as light as a mountain, others thousands of times the sun's mass. Their age is another key difference. Stellar black holes are younger than the stars that made them. But primordial black holes could be the oldest objects in the universe. If they exist, they formed within the first second after the Big Bang, true cosmic fossils. Their distribution would be different too. Stellar black holes are found in galaxies where stars live and die. Primordial black holes could be scattered everywhere, even in the vast voids between galaxies. They might float freely through intergalactic space or form invisible halos around galaxies. Finding a black hole where no star could have existed would be a smoking gun for a primordial origin. The differences in origin, size, age, and location make primordial black holes a unique cosmic mystery. Discovering them would open a new chapter in our understanding of the universe. One of astronomy's biggest mysteries is dark matter, the invisible mass holding galaxies together. We see its gravitational effects, but we don't know what it is. For decades, scientists have searched for new particles but found nothing. What if dark matter isn't a new particle at all? What if it's made of primordial black holes? They're dark, no light escapes, and they have mass, so they fit the bill. If the early universe made enough of them, they could form the invisible halos we observe. There's a sweet spot, too big, and we'd notice. Too small, and they'd have evaporated by now. But black holes with masses between an asteroid and a few suns could still be around, and could make up all the dark matter. Finding even one in this range would be revolutionary. Primordial black holes could be the hidden universe we've been searching for. At the heart of every large galaxy lurks a supermassive black hole, millions or billions of times the sun's mass. The puzzle, how did they get so big, so fast? Growing from a stellar black hole is too slow, like filling a pool with a teaspoon. But if galaxies started with a large primordial black hole as a seed, the process would be much faster. These seeds could anchor the first galaxies, growing as the galaxies grew. This explains why we see massive quasars so early in the universe. The seeds were planted at the beginning and galaxies formed around them. Proving this would link the history of galaxies to the physics of the Big Bang. The giants in the shadows might finally have an origin story. If primordial black holes exist, how do we find them? They're dark and likely small, so we look for their effects. One method is gravitational lensing. A black hole passing in front of a star bends its light, causing a brief brightening called microlensing. Surveys monitor millions of stars for these events, searching for unseen massive objects. Another method, listening for gravitational waves from black hole mergers. LIGO and Virgo have detected waves from stellar black holes, but primordial black holes could produce signals with unusual masses. Every detection helps refine our models. For the tiniest primordial black holes, there's Hawking radiation. As they evaporate, their final moments would be a burst of gamma rays. Telescopes scanning for gamma-ray bursts could spot these explosive endings. Finding such a signal would be definitive proof of tiny primordial black holes. The search is on, using every tool we have. Each clue brings us closer to solving the cosmic mystery. The James Webb Space Telescope is revolutionizing our search for primordial black holes. With its powerful infrared vision, Webb can see the earliest galaxies, potential evidence of black holes acting as cosmic seeds. It can also spot accretion disks, gas glowing as it falls into a black hole even in the distant universe. Finding a bright point of light where no star should be could reveal a primordial black hole at work. Looking ahead, the Laser Interferometer Space Antenna, LISA, will detect low-frequency gravitational waves from massive black hole mergers. LISA could hear the background hum of primordial black hole mergers across the universe. It might even detect the gravitational waves from their very formation in the Big Bang's first second. With tools like Webb and LISA, we're moving from theory to active discovery. The hunt for primordial black holes is entering a new era. Soon we may have the evidence we need. The universe's oldest secrets are within reach. Why do primordial black holes matter? Because they could answer our biggest questions about the universe. They're a direct link to the Big Bang, a physical probe into the first second of time. If they're the dark matter, we solve a 50-year-old puzzle without inventing new particles. Their discovery would reshape our understanding of how galaxies form and evolve. They could explain how supermassive black holes grow and test the limits of physics. Each one is a tiny laboratory for the universe's most extreme laws. The search is about curiosity, about understanding where we came from. The atoms in our bodies were forged in stars, but the seeds of those stars might have been planted in the first moments of creation. By searching for these cosmic ghosts, we piece together our own cosmic history. Whether we find them or not, the quest pushes the boundaries of knowledge and technology, and it deepens our appreciation for the vast, mysterious universe we call home.